hopefully, by the end of this quick webinar, no, you get already an understanding of what is SDN, software-defined networking. Have a brief understanding of what the SDN architecture is, its components, and overall functionality. Understand also or list down the benefits, advantages, and limitations of SDN. And finally, give you an overview of the different SDN model types. Similarly, or you may have noticed that even in the content of the course itself, no, SDN can be applied into different use cases. So yun yung i-discuss ko din natin dito briefly. Okay? So first off, no, what is SDN in general? So SDN, this is a technology that although you may have heard of it, or it's a new term for you now, some of you in fact, no, this is already being used for a significant amount of years already. So this is an approach to networking that uses software-based controllers or application programming interfaces or APIs to communicate with the underlying infrastructure and direct traffic of the network. Think of it this way. In our transport network, normally, the network themselves is interconnected via switches. Okay, so we also have our routers. And in terms of its functionality, no, we can say that a switch in general, no, is logically split into two parts. You have what's called the data plane, which is where the packets are being forwarded. And finally, you have the control plane, which is where the configuration or the routing is set up. So all of the transport devices that we have, take note, this is not just limited to our switches, but also in our routers, now in our L2 or L3 devices, layer 2 or layer 3 devices. Okay, but here we would be focusing more on the switch because in SDN, this is also the primary component that you would be using when you set up your SDN. Okay, so in a traditional network, meaning how we would be implementing an IP topology, normally it would consist of switches interconnected into a network, and we rely on the individual switches configuration plane to set up the proper routing of packets. So meaning na kapag naka-receive, example, itong si packet, si switch A ninyo, let's name this a switch A, no? We would use the underlying protocols configured in the control layer in order to determine where the packet would then be forwarded to. Okay? So, this is how majority of our IP networks are managing or performing traffic management within the IP network. Okay. Now, there is a challenge and a certain limitation on traditional networking applied this way. One is that in terms of configuration, you have to individually configure each of the switches, no, with their proper protocols for convergence or network convergence to occur. So pag sinabi natin network convergence, this is the scenario where the entire network in general terms is coherent, wherein if say I give the network a certain packet, it would know where to process that packet from source to destination. So yun yung tinatawag natin network convergence. Now, in a traditional network, this type of convergence can be a bit of a challenge, especially if the network itself is already complex, consisting of several nodes. It would be simple if, say, I just have 1, 2, 3, then 10 switches, no? But what if you are already trying to design an architecture that consists of, if not dozens, hundreds of switches, okay, hundreds of L2 devices, hundreds of L3 devices? How can you make sure that the proper protocols and routing tables are configured to those switches? Okay, especially if, say, that network is already existing and you plan to deploy a new switch, no? So it's a bit of a challenge, in fact. And up to this day, no, it is still also a challenge on how it is being implemented. Okay, so one way for us to at least simplify configuration is to have a centralized means of setting up the routing tables and the control and the protocols to be used across our switches. And that is essentially how SDN is implemented. You're taking the um, control level of the switches, individual switches, and centralizing them as one control node. Okay, this means that each of the switches would just be essentially dumb pipes in the form of data forwarders. Okay, and the centralized control node would now be the SDN controller. Okay, so in the illustration above, you'll notice here the comparison that the control plane is now centralized as the SDN controller. Okay, and that is where SDN would come in. It is the separation of your control plane and your data plane through the implementation of a controller. Now, in the SDN architecture, the software is decoupled from the hardware. SDN moves the control plane that determines where to send traffic to software and leaves the data plane that actually forwards the traffic in the hardware or in the actual switch itself. This allows network administrators who use SDN to program and control the entire network via a single plane of glass via the SDN controller. Okay, now we have an architecture to follow if we want to implement SDN. Consider this to be a sort of like a simplified architecture, but it would mainly consist of 4 main parts. So those 4 main parts, the first 3 are the layers themselves. You have the infrastructure layer. This is where your data forwarding switches are. You have the control layer. This is where your SDN controller is. And finally, you have your application layer or your end devices or services. Okay. Now, these 3 are interconnected via what's called APIs or application programming interfaces. OpenFlow, which is a protocol, is a southbound API, meaning this is the API used by the SDN controller to communicate with the underlying forwarding switches. More of these ones, in fact, in module 3. Okay? So I won't be discussing what OpenFlow is, pero as a protocol, pero just keep in mind that OpenFlow is just one of the many southbound interfaces used by the controller to communicate with the switches. Okay? So ito yung parang high-level descriptions of each. So the application layer, this contains the typical network applications and services, examples of which you have your load balancers, your firewalls, your DNS, your databases. Okay? Where a traditional network would use a specialized appliance such as a firewall or load balancer, there are some capabilities of the SDN architecture wherein these applications can already be embedded also as part of the SDN controller itself. So meaning, due to the availability of products nowadays, no, lalo na yung mga nag-o-offer ng SDN solutions to organizations, the firewall and load balancers can already be applications also found inside the SDN controller, instead of it being a separate physical machine altogether. Okay? Regardless, no, it is still in the application layer. The control layer, ito mismo yung ating SDN controller. This represents the centralized controller software that acts as the brain of the software-defined network. This controller resides on a server and manages policies and traffic flows throughout the network. In other words, think of the SDN controller as a server who manages the switches. Okay? There are some solutions that offer the controller to be a physical box. Some of them are just offering it as a virtual machine. So in other words, there are also vendors who offer the SDN solution, no longer including hardware components, but just everything to be pure software. It's also possible. Okay? Kasi ang kailangan nyo lang naman dito is yung functionality ng controller. So why not offer it instead as a software bundle through a virtual machine? You purchase that virtual machine. If you already have an existing server, just spin up a VM instance, install the SDN application there, and then boom, you have the SDN controller. You just have to make sure that you install the necessary drivers. If you have existing forwarding switches, that would allow the controller to communicate to said network switches. Okay, so that's one solution. In fact, that's one possible solution that organizations can use to implement SDN. Okay. You also have the infrastructure layer. This is where your physical switches would come in. Now, from a traditional network, wherein you also depend on the switches running config to set up the protocols and to set up the routing tables. Once it is already implemented as an SDN, it essentially becomes, quote unquote, no, a dumb forwarder. Kaya siya ang terminology dito ng it's not to degrade the functionality, pero kaya siya tinatawag na dumb forwarder na lang. It's because majority of the intelligence is already placed in the controller itself. So essentially, ang gagawin na lang niya is kokopihin na lang niya yung configuration from the controller, and depending on that configuration, yun yung gagamitin niya to forward the packets. Okay? So that's the infra layer. Now, how the controller communicates with the forwarding switches, you now depend on what's called APIs, application programming interfaces. Now, there is really no formal standard on how you can implement an API. It actually depends on what type of protocol you want to implement in your SDN environment. Some of them, example, is OpenFlow. It uses its own unique API set. Some of which, like Open Daylight, it also uses its own set of APIs. These are actually also configurable and customizable. Okay? So there. Now, in common use cases, majority nowadays, if you have an open source, open SDN environment, and when I say open here, it means that majority of the applications running there are primarily open source tools and software, no? Ang nagiging de facto standard is for northbound, gagamitin mo is Open Daylight API. So meaning pag sinabi mong northbound, ito yung ginagamit mo na application from SDN controller communicating to the applications. You use Open Daylight there. And for southbound, you use OpenFlow. But again, we're not just limited to these two. There are also others. You can even use existing protocols to support SDN. Example of which, if you have BGP, no, pwede mo rin siyang implement dito. Okay? So, how does SDN compare to traditional networking? So, notice, no, ang focus na talaga ng SDN is its flexibility, no? But however, no, just because something is flexible doesn't mean that it's already the best, or it is the be all and all solution. No? SDN also has its own limitations. But if we're going to compare this to how traditional working is being done, SDN is software-based, meaning that, again, if I'm going to take my example a while ago for the SDN controller, it becomes software-based because you don't necessarily have to purchase a dedicated hardware for SDN. You can just purchase a software bundle and install it to an existing hardware that you might already have in your organization. Okay? Apart from that, SDN is also centralized in a way that the main control plane is already found within the single node, which is your SDN controller. Contrary to a traditional networking wherein the management plane is still separated across several devices. And having said that, no, one feature of SDN is its centralized configuration and resource provisioning. Say, for instance, one of the switches in your topology goes down. In a traditional networking, you have to rely on link redundancy and even existing protocols that would allow the remaining switches to communicate with each other. In SDN, however, if a switch goes down, the controller can immediately detect that something's wrong with the topology, and from there, revise its own configuration files, which would then be forwarded to your forwarding switches. Yun na ngayon yung gagamitin ni SDN ng mga forwarding switches. Ang technical term nito, it's really more of like the flow tables. Ito actually would be discussed in module 3. Pero yung configuration files na can be found in what's called flow tables. Yun yung ginagamit ng controller to configure the routing of your forwarding switches. Okay? Then lastly is security is centralized. Now, just because security is centralized doesn't mean that it is already the better option. Okay, why is that? Because remember that in security and vulnerability assessment, if you only have a single node, you have to make sure that that single node is properly enforced security-wise. Kasi if you tend to, or if there is a vulnerability found in that single node, it's already a major risk. Contrary to, say, decoupling or decentralizing the control across several nodes. Okay, so again, dito papasok ng concept na security in itself, ito yung parang medyo, I don't want to say a weak point, pero something that is a bit of a limitation also to SDN. Kasi nga sinentralize nyo na lang siya as a single controller, it becomes a security risk kasi it's also a single point of attack. Okay? Yes, somebody raised a hand there. Any question po? Yes, sir. So the floor is open. Sir Fernando Blanco. Sorry, you've raised your hand. May question po? Wala naman po. Sige, so I will just continue on, no? Okay, so what are the benefits of implementing SDN here? No? So here are just some high-level benefits here. So first one, simplified policy changes. With SDN, an administrator can change any network switch rules when necessary. Okay, it doesn't have to be on the device level already. Once a policy is configured, it can just easily be propagated to all of the forwarding switches via a single pane of glass. No? Another one is network management and visibility. No? Only one centralized controller is needed to distribute policies to the connected switches. This is contrary to, say, logging in via CLI to the individual devices themselves and then individually configuring them one by one. Okay? Next one is reduced hardware footprint and OPEX. Again, pumapasok ako doon sa scenario ko kanina na if you want to implement SDN, you don't necessarily have to purchase any underlying or specific hardware to have it in your network, right? You can just purchase an SDN controller via a virtual machine or a software application. And if you already have an existing server on your architecture or in your network, no, you can actually utilize that instead. Hence, you're saving up on your hardware footprint and potentially operational expenses as well. Kasi it's one less hardware being maintained. Okay? And of course, lastly is network innovation. So because it is already software defined, it opens up numerous possibilities on how SDN can be applied as a use case. No? So it can support the emergence of SDN wide area networks. It can be implemented in telecommunications. It can be used for access networks. It can be used for telemetry, among others. Okay? Now, just because it has its benefits doesn't mean it does not have its challenges. So of course, meron din siyang limitations and challenges. So what are these? No? Kanina nabanggit ko something about security. So that is definitely one. So security is both, I think of yung security aspect ng SDN to be sort of like a double-sided coin. On one face, you have the benefit of just maintaining a single node or enforcing security only to a single node. But because it is just a single node, it becomes a potential single point of attack, no, if proper vulnerabilities are not catered to. Okay? So that's one. Another one, no? Unclear definition. Why is that? Okay, SDN kasi, although we have Open Networking Foundation as a foundation overseeing open flow as a protocol, it is just for the open flow protocol. Okay? With openness as a whole, no, there is yet to be set as a clear set of standards in implementing SDN. Okay? So this means different vendors might offer different approaches to SDN. Some of them would be hardware specific. Some of them would be software specific. Some of them, in fact, would go virtualization all the way. Okay, so depende siya. And because of these numerous means of distribution, how it is being offered in the market, no, there is really no clear-cut way on how you can implement SDN. And it can be a challenge. Okay? Some networks might use OpenFlow as its southbound API, while some might prefer, say, BGP. Okay? So it's really a bit unclear at the moment. And having said that, no, there's a bit of a market confusion here. No? Some networking initiatives are often mistaken for SDN, okay, including white box networking, disaggregation, automation, and programmable networking. So while SDN can benefit and work with these technologies and processes, it remains a separate technology. Notice na ang key differentiator ng SDN is the separation of control plane and management plane. It is different to network disaggregation. Okay? Yes, you can implement disaggregation in SDN, pero it doesn't mean that disaggregation is already SDN. I hope that makes sense. So ganun siya. Similarly, automation can also be implemented on its own. SDN actually uses network automation. Okay, so it's a bit of a blur, in fact, no? So there. Now, lastly, slow adoption and cost. So SDN technology emerged at around, imagine, 2011. It's not really haven't gained traction in the telco perspective, no? Kasi I myself, I come from a telco background, no? SDN in the telecommunications in mobile broadband hasn't yet been fully adopted, contrary to, say, in the IT or enterprise environment where it is pretty much commonplace. Okay? So imagine, it emerged at around 2011, and yet up to this date, 2023, more than a decade has already passed. No? Still, innovations and emerging technologies continue to sprout for SDN. So just because it emerged in 2011 doesn't mean that it's already outdated now. It still continues to evolve, in fact. Kaya nga doon pumapasok yung SDN, NFB. SDN actually came earlier than NFB. Pero nowadays, it can already be used also as to complementary technologies. Nowadays nga with the onset of 5G, there are already some vendors who are offering virtualized containers with SDN. So if you're not familiar also with containerization, this is another separate technology that is somewhat similar to virtualization. No? But it abstracts more pa on the software level. Imagine having that level of complexity in your network applied with SDN. So para bang it has already become complexly convoluted, so to speak. Pero it's there. It's already available right now. No? So it continues to evolve. No? Yun lang yung point ko dito. Okay, so for how it is being applied, no, while the premise of centralized software controlling the flow of data in switches and routers apply to all that SDN, there are different models. Okay, so how you can apply SDN, these are for high-level ones. You have OpenSDN, SDN the APIs, overlay model, and hybrid. So we'll just briefly discuss them. No? Think of this one as sort of like, what kind of SDN can you apply in your network? You can have what's called Open SDN, wherein the administrators use a protocol to control the behavior of physical and virtual switches. You can also have SDN just by implementing an API. Okay. You can also have SDN just by implementing a virtual network on top of an existing hardware infra. In other words, you use another a virtual network, example of which is VXLAN, no? Running on top of your physical network topology. So kaya siya tinatawag na overlay kasi meron kang traditional na transport layer ninyo, and then on top of that you implement SDN. Okay, so that is overlay. Then finally you also have hybrid, wherein, say, you have your traditional fiber optic transport network, no, and then it converges to your IP network which uses SDN. So pwede din siya. That's what's called hybrid. Okay. So SDN inside NFB. So right, my other question is, can we still run virtualization inside virtualization? So think of SDN is not necessarily inside NFB. Think of them to be sort of like a complementary to both. Okay, so you can actually have SDN without NFB and vice versa. Okay. Kaya nga, in some telcos nowadays, no, they can implement SDN without having virtualization in their network. Okay, so think of it na parang complementary siya, pero not necessarily a requirement for each. Although, ang lumalabas na trend nowadays is that they implement both at the same time. Pero technically speaking, you don't need both to run each other. You can have each of them running individually. Okay, so virtualization. So having said that, no, virtualization inside virtualization. Okay, good question. There is what's called virtualized containers nowadays. Okay, so this is not related to SDN by all means, but I'll just briefly discuss it here. We know virtualization as sort of like a technology that allows us to have computers inside my computers. So that's virtualization. Okay. Suppose, say, inside my virtual machine, I have a smaller application. Example, my web server is running inside a virtual machine. The web server has several components inside that can be reused by other applications. Example would be databases. Okay. Suppose say, itong web server 1 ko na nasa loob ng virtual machine, it's running a database and they want that database to be reused by a different web server, and I don't necessarily have to create a different virtual machine to host that web server. I can actually have a smaller component called the container that would allow it to integrate that to that existing database. So that is where virtualized containers would come in. It's kind of like you have a virtual machine, sa loob nun nag-run ka pa ng maliit na component called the container. Yun ang mas madalas na ginagamit natin ngayon na technology nowadays. Instead of just having virtualization inside virtualization. It can be done, but there's frankly no practical use for it. Contrary to what I have discussed, which is virtualized containers. You can look it up, virtualized containers. Okay. Yes, correct. Kubernetes and Docker. So to clear it out, no, Docker, this is the container engine. This is similar to what a hypervisor would do. So ang hypervisor kasi, ang ginagawa niya, it creates virtual machines, okay, wherein you can install an operating system inside. Docker is a Docker engine or a container engine that allows you to create containers. A container doesn't necessarily need an operating system to run. It is more atomic in size. Mas maliit siya compared sa virtual machine. Okay? Now, if you plan to implement several containers, several Docker engines across several servers, you need a way to manage those. That is where Kubernetes would come in. Okay, so ako, I have a bit of a background on cloud computing. No? If you're familiar on OpenStack, which is a cloud operating system, OpenStack runs hypervisors inside its servers. So meaning, OpenStack manages KVM, example as a hypervisor, similarly to how Kubernetes would manage a Docker, which is running in your servers. So ganun ko siya ibibigyan ng analogy. Kubernetes and Docker is to containerization, whereas OpenStack and KVM is to virtualization. And you can actually also combine them into one. Okay, so I won't dive much into that because it's no longer SDN related, pero it is really more on cloud computing na in general. Okay, I hope I was able to answer that question. No? Okay, so I believe that's the summary on what my talk would be about. So what can we pick up on this overall discussion natin? So definitely SDN as a technology is continues to grow. It continues to evolve. No? It started off as a technology supporting our IT and enterprise environment, pero eventually it evolved in a way that it can also cater to other use cases. No? You can apply SDN via a simple architecture wherein you have 3 layers, wherein those 3 layers communicate via an API. Okay? Just because we have SDN doesn't mean that it is already the end-all be-all. It would also have its own advantages and disadvantages. Okay? So as I have discussed a while ago, and right now, we can implement, you don't necessarily have to go all full-blown, overhaul the entire network to implement an SDN. You can just implement bits and pieces of it in your existing network and call it a day. Depende pa rin siya dun sa end requirement ng operator or organization. Okay, that's why we also have different model types of deployment. Okay?